So very good evening, guys. So let's start. See, I've removed all the ACL just to give you guys clarity what all the behavior of your firewall will be when your traffic is going from inside to outside. So let's first get this router here. Let me start debugging on all the routers here. See, on this router one, we will be running debugging. Let's say debug IP packet details. On router one also we'll do debug IP ICMP. Okay. So if you check it on your ASA, show run policy map, you will able to see what are the policy your ASA is mapping. Means based on this policy, you will be going to take the decisions. So when you see this policy, we will be going to add, see, this is by default policy what you will be having. We'll be going to create our own policy also. That we'll discuss in later sessions. But currently, this is by default, you will be going to check. These are all protocols you'll be going to inspect when your traffic is going out, correct? So similar way, see, there is no ICMP. And previously I was having, see here, previously I had allowed this with the ACL. So I have removed this ACL here now. So there is no ACL is available here. So let's verify. So access list. We removed it. So let's say show run access group, or let's remove now. Access group, we don't have anything. Now let's say no and remove this ACLs. So let me first get it from show run access list. If you give whatever access list we gave, that will be shown here. So let's say I don't want both the ACLs, so I'll first remove all. Okay, and see. Show run access list. We don't have any ACL, we don't have any access group. See, usually on router, what we do, we create ACL. On router, we'll be going to create a ACL get created, and on inbound or outbound interface, it will get implemented. So here you'll be implementing it on a particular interface. So here we'll be using access group to apply this policy. For what reason? To apply these policies. Okay. So now, currently, if you try to ping from your inside router to the outside router, 11.1.1.125, see, your traffic is not going. Currently, there are interfaces are down. So let's verify the interfaces are up. So let's see interface gig 0/0. No shut. Interface gig 0/0. Enable configure terminal interface gig 0/0. No shut. DNS, it's fine. ASA, it will be not down. Interface IP brief. And router one, it's already up. Now check. If I ping, see what happened. You are receiving the request, but you are not getting respond back. Why? Because see, from router one, when you will be sending this request here, right? You will be using what all informations? You'll be using source IP. You'll be using destination IP. You'll be using protocol. Then you'll be using port number. So this other information is on what we require. So we know we are going from what? 10.125 to 11.125 router, like 10.1.1.125 to 11.1.1.25. Protocol currently we are using one ICMP, and port number will be the random for our end. So this is what the request is going. You're going with the type. What is the type? ICMP type you are using, that is 8, echo request. So it is echo request. This packet will go here, correct? So this packet will go, and now here when this router will be going to send the response, the similar way we are having source IP, destination IP, we have protocol number, then we are having port type, and then we'll be having ICMP message. Or if it is ICMP, then type messages. So when you be pinging, now it is going from what? Source will be what? 11.125. Destination will be 10.125. Port will be what? Random. And type will be 0. Correct? ICMP type 8 request and type 0. You guys have studied it, right? See here, all this information is required. So you can remember this. So let me just share. Type 8 will be echo request. Type 0 will be echo reply. Okay. Type 3 will be destination unreachable, and type 11 will be time exceed. So this 4 you need to remember for now. Okay. So when you will be going to get a respond back, right? You will be going to respond with echo reply, and your firewall will be going to check into your instruction in your con table if there is any entries available. If there is any ACL is configured, then only your ASA will be going to permit it. Correct? So currently we don't have any ACL, and we don't have any policy also which we are allowing it. Correct? So show run policy map. Here no ICMP is there, so request will be not there. You can allow with ACL also, but yesterday also we'll discuss fix up protocol ICMP. If you use, it will be going to add your ICMP request into policy map, and here you can verify that in your policy map will be having inspection now for ICMP. Will you get response now? Let's verify. Yes. Now response is there. Previously response was not there. Correct? This is fine when you will be going from here, and let's verify how we configured any HTTP here. So do show run section HTTP. No. So let's create username will be your admin. Privilege 15, password is CCI. IP HTTP server, IP HTTP secure server. IP HTTP authentication. We will be doing locally. Okay. Now, see from outside, I'm able to ping or not. Let me ping. Do ping 10.1.1.125. See, packet is routing means you're sending this packet. Your packet is going. Are you getting any response here? We are having debugging here, right? So your request is not coming here. Why? Because of this. When you are going from low security to higher security, you will be not able to go directly. You need to allow those traffic with policy. So let's say here we'll be going to create one access list. Let's call ISP permit IP for any. Okay. And we'll be going to add this into access group. So we'll call access group ISP. Then traffic is what? Incoming. And we'll be going to apply it on the interface. So interface, and it is outside interface. Verify now. See, you will be reachable now. Correct? So this is how you'll be going to communicate. These all are things you need to know when you will be going to work with ASA. Correct? So now today's task we'll be going to do, that is with respect to your static part. Correct? So we yesterday discussed little bit about static part, but further, like yesterday's technical issue is resolved. So device is now functioning fine. So we'll try to do static part. First, understand what the static part is and why it is required. So to make you guys understood, we'll go to packet tracer and we'll do one small lab there. So consider here, you are having two switches, router, and two hosts. Correct. Now let's take the IP. Let's here, this network will take 10.10.10.10/24 network. This will be acting as a default gateway for these two laptops. And here we'll take 20.20.20.20. They will be acting default gateway for this laptop. This is 20.1 and other will be 20.2. This way we'll be going to configure the IP 10.1, 10.2. Here we'll take 192.168.12.0 network /24. Router 1 will be acting as 12.1. Other side will go with 12.2. Similar way, it will be 23.2, 23.3. So this network will be using here, correct? Let's quickly configure these devices. So graphically only I'll be going to configure here, which will save our time. Gig 0/0 will be using 192.168.12.2. And here we'll use 192.168.23.2. 3. Now we have to go for router 3. Gig 0/0 of this router will be 23.3. and gig 0/1 will be 23 dot like 20.20.20. Let's assign IP addresses to this laptop. Let's say this will be your 10.1. So we'll assign this 10.1.1.1, 25.25.25.0. This will be acting as 10.2. Okay, so see now here. If we try to ping from one laptop to another laptop, or let's say if you want to ping to router's default gateway, can we able to ping? Yes. Adarsh, Viraj. See, if I try to ping to my default gateway, 10.10.10.10, you're having reachability. Correct? Now, why you are having reachability? Because when you ping to this router, your request will be first received by switch, and switch will be flooding this information. So this is in the same subnet, so router will respond. See how? On other side, I'll show you with graphics. Now see how request will be going. Switch will be first performing ELF, error detection, learning source MAC address, and forwarding. This function what switch do. And lastly, then you will be able to receive the ARP. Then you will generate ICM pin. This will be unicast now, and you will get the response. This is without default gateway, you will be going to get it. See your router's configuration. Have we provided any default gateway here? No. Default gateway, when we require default gateway, why we need a default gateway? Yes, Viraj. Others.
To know router that or on the PC that this is the exit path for the another node.
If you want to go to any other network, then you need to go and submit your request to the default gateway, right? If default gateway is not there, can you go and ping to 20.20.20 network?
No.
See what happened. Your packet is got generated here. Will flood it. And it dropped. Why? Because you don't have the default gateway information. And if you add this default gateway information, router need to check, and that information will be going to pass to the next router. So if you don't have the default gateway, then how it will work? It will not work, right? Now, similar concept will be going to use with the ASA. How? Consider you are having one site here, and into that site, some of devices will be non-routable device. These devices will be not having the default gateway. So then how you will be going to communicate with them? If you see here, why this router is responding you? We checked it, right? You don't have the default gateway. Till you ping, you will be able to communicate with your router. Verify here. You don't have the default gateway, right? And if you ping to the router, till you will be able to reach to the router. Why? Because your router is in a same network, so you'll be able to reach. So with the same concept, we'll be going to use with the ASA, where consider now this is your ISP. This ISP will be having two sites. Let's say you are having two websites, or you will be having two networks. To these two networks, you'll be going to connect. And after this, we'll be having another network. Now, if anybody from outside world now want to communicate within your internal, call it website, call it rack, or call it a network, you will be able to convert your address. So he will be using what address here? Public address. So here you will be using what? Public address. I'll be writing public address only. And here you'll be using private address. So what you will do, when you will be going to ping, right? Or you'll be going to take, let's say, HTTP request of this device. So you will be going to submit your query here with the public address. ASA will be going to filter it and like translate it into the private address. And this router or this network is not having any default gateway. Till you will be communicating because you will be in a same network. And this is what we have to achieve with ASA. So this will be going to achieve with the static part. So you will be going to map it to the particular port number. Okay. So see how we'll be going to mapping it. So here, consider you are having let's wait what happened to server. Let me check with the network connectivity, guys. Here some issue is there. I'll just connect to the physical cable. So it is having high memory utilization here. So let me just stop the recording for now. I'll just pause it. Hey guys, are you there? Adarsh, Viraj.
Yes, sir.
Yes, sir.
Yeah, so let's start. We have to do everything again, guys, because the configuration is gone. The EVNG utilization on server was full. So we have to remove the memory from there. And once you remove the memory, your whole configuration is gone. So let me check how much configuration is gone. Whatever we have stored, at least that much if we are having, then it's good. Okay, good. So we are having IPs here, so no problem. So let's bring this interface up. And on AC will go. Okay, so show interface IP brief. All interface are up. So let's first verify access list. So we are having access list, which we removed last, right? So again, we need to remove. So we'll use fix up protocol ICMP to fix it. We'll put it into your modular policy. Then we'll first say show run access list, which is already there, right? So let's remove these access lists here. So at a time, we'll remove both. We need to copy this also. Okay. Show run access list. Say no to this access list also. So no access list now. Show run access group to check any interface is there, which is applied with this. No. Now we only need to create one access list. So we'll say access list. Let's call ISP. Will permit IP for any incoming, any source on any destination. We'll be going to apply it on interface on group, which is ISP, on incoming traffic on interface, and we'll be going to apply it on outside. So we'll verify from outside. Let's put the debug on this. Do debug IP ICMP. Go on router outside router 1. Do ping 10.1.1.125. Reachable? We'll also put one debug here. So do debug IP ICMP. Okay. And now let's take internet PC here. From internet PC, we'll try ping here 10.1.1.125 pinging. Let's try to get the graphical access. First of all, this router might be not having any HTTP configured. Let's verify. No. So username admin, privilege 15, password is CCI. We'll be using now here IP HTTP server, IP HTTP secure server. And authentication will be doing locally. Okay. So IP HTTP authentication local. Try to get access from your internet PC here. And we should be able to get the access for your router 10.1.1.125. And yes, it's working. So good. So your HTTP at place. So let me just write it here. So next time we don't need to configure. On ASA also, I'll write it. Done. So now see what we'll be going to do. As we discuss, we will be having two networks inside. So we'll be having here one router, which will be acting as one website. This is your one router. Okay. And this will be your another router. Okay. So what we just discussed previously, first we'll cover that and then we'll go for static part, because we have done one practical here on packet tracer, right? This practical is destination NAT we'll be using with. So how one non-routable device can communicate with other device here, that we need to understand, correct? And this is really easy. So we'll be going to understand this. Okay. So let's see now how we'll be going to implement with ASA. So first we'll do a destination NAT, then we'll go for static part, and then lastly we'll do policy NAT. Okay. So what is our goal now here? If you see from router 1, outside router 1, if you ping to the router here, you are getting response. Why you are getting response? See, you are having request coming from which device? 11.1.1.125, and you are responding here, correct? So your request coming from this and you are responding for this. So you are giving source address as your address, correct? And why you are giving this? Because in your routing table, you will be able to see this information. Do show IP route. You have one static route configured, which is a default route configured toward your ASA, which is 10.1.1.10. That's why any network, if it is coming toward you, you'll be going to submit your query to ASA and ASA will be going out. But what if you are having a device which is not routable? Like we discuss here in packet tracer, if we discuss, right, if these systems don't have any routing table, how you'll be communicating outside? We discussed this. They don't have any default gateway information. If any non-routable device can't go outside the network, they will only have communication within the LAN segment, within that segment only. They will not cross your router's interface here. So in this case, what you can do, how you can have the communication? You can you can translate your address, whatever address you will be going to pass. ASA will be going to translate that public address into the address which this locally is used. So they will communicate. So to do this translation, we'll be using couple of object to translate, and then we'll be going to achieve this. So see here how we can achieve it. So currently it's working. You are having the reachability, correct? We just verified we are having the reachability. Now we'll remove this no IP route, or let's say do show run section IP route. We'll copy and we'll say no. And now if you check, if you ping, you're not having response. See, this system is receiving the packet, but you are not able to respond back because your source IP and destination IP is correct. ASA will be knowing it, so they will be passing here, but your router don't know where to respond. So they're responding, but it's not going anywhere. So to understand this in much more detail, you can debug here with IP packet details. First of all, undebug all, and then say debug IP packet details. And now if you ping, you'll get detailed information there. What it is saying now, it is saying this packet is not routable. Let's verify. Take any packet. Let's take the first packet, what we got generated here. Now, if you read it, what it is saying, this is the source. This where you received the request on this interface gig0/0. Destination address was 10.1.1.50. Length was 100. This is not required, so we ignore it. What was the request message? It was type 8. Code is 1. This is not required. Then we will be seeing what? Okay. Forward check fall. Then will be what is saying? Fib. Forward information base table IP version 4 packet processed. Deal with this packet. Route packet from the gig0/0 to the source 11.1.1 and destination is what this 10.1.1. So this is the what information is coming towards you. We are checking it on router 1. So when your packet is received on you, this is what information you get. And default gateway is who? Router 10.1.125. This is the receive entry. Correct? This is what you will be having in your Cisco Express forwarding table. These are our fib table information you are having. Under that, you will be able to see. Now, when you try to respond back to this, correct? See, routed via what? RIP, routing information, like routing information based table, router information based table. Based on this routing table information, you will be trying to route this packet, which is 11.1 to destination 10.1. This is in perspective what? In router 1's perspective, this information is correct. But when you will see source as 10.1.1.5 and 11.1, then here you will be going to have failures. So if you read this all messages, you will be able to follow what all things are happening in background. But I'll directly show you what we have to look. We have to look here. When you try to send your respond for this, what it is saying? Unroutable. This is what we have to see. Now, why it is saying unroutable? Because when you received this packet on you, you'll be going to check your table, IP packet table you checked, IP next hop table you checked. If none in next hop, then debug one. This is another way of coding. You will be returning in such a way so you can understand it. So you will be looking for what? Default gateway, not enough information to forwarded via who? Fib, forward information based table. So there is no enough information available with respect to what? This default gateway or either to the network. So we'll be checking with fib. So in your IP table, IP version 4 packet, it is failed for forwarding. So you can't forward this packet because you don't have enough information. So this packet is unroutable. Okay. So you understand, okay, I can't route this packet because I don't have the enough default gateway information to forward this. So what information I'm missing? Default gateway information, because we removed it, correct? Until now, we will use your ASA to translate your public address into the local address. So you will be able to communicate with the non-routable device. So this device is not able to route any packet. If you check, you will be only able to communicate within your LAN segment, but you will not go outside your LAN segment. Let's verify this as well. Go to the router 1 and try to ping your PC here, which is 10.1.1.5. And you are having reachability, correct? Success. Routing is success. So you got the reachability. Similar way, you can check with your router, another router, which is 126. Success. Correct? And if you try to ping now outside 11.1.1.125, so you will not have the reachability. Failed. Failed. Correct? So now we'll go on ASA. And now we'll be going to configure your destination NAT. It will be allowing us to translate your public address into the address, which will be going to communicate here with the non-routable device as well. So how? See here. So we'll be going to create one object network. Let's call inside address of your router 1. Which address? We are talking about host, which is 10.1.1.125, router 1. Here we'll do one NATing. When you are going from inside to outside from router 1, statically we'll be going to convert your address into something else. Let's convert your address into 11.1.1.25. Okay. Now ping from this router to this router. Let's see what is your identity here. 11.1.1.255. Sorry, 125. Do ping. What happened? Oh, we are on ASA, no? Sorry. We need to ping it from router 1. Do is not required. We are at privilege. And check. Will not have reachability, but if you go on your router 1, so your packet is not going anywhere, failed, because you don't have the information how we can reach out to this network only. So we'll convert your incoming address first, which is coming on your ASA with this. So let's call first come out object network. So previously we done for inside IP, we make understood which is our inside IP. Then we'll say now who's my outside IP. So called outside IP, outside router 1. Who is the host? Without like with host we are dealing with. So this is the host 11.1.125. This is the router 1, outside router 1. So this router will be going to translate from outside to inside. So far we translated from inside to outside. Now we are doing reverse translation from outside to inside. When this will be coming in, right, we will be going to convert this into statically we'll be going to convert into 10.1.1. Any address you can get in this subnet. Okay. So your identity will be 10.1.1 like 25. Okay. And let's Try to ping now. 1.1.25. And you are having the reachability. Can you see? You are pinging to 11.1.125 until you are getting reachability. Check it on your router here. Can you see here? Now, this will not give you any information. You can only see here it is successful. Now, how it is successful? Now we'll close this debug and we'll understand with ICMP now. So debug IP ICMP. And see here, from outside router, if I ping inside now, you're having reachability. How? See, you can verify here. Do this router have any routing table? Like any route here? No, you don't have any default route or no static route, no OSPF, no EIGRP. You can verify with this command, do show IP protocol summary. Do show IP, do is not required here. Do show IP route. Sorry, not route, it's a protocol summary. We don't have any protocol is running. How we can verify? See, I'll show you. Let's say I started here a BGP. Router BGP 100. So you can verify with this command, you will be able to see do show IP protocol summary. BGP is enabled. So we don't have any protocol enabled here. That's how you can verify here. No router BGP 100. Do show IP protocol summary. No protocol is running. Correct? So till we are having reachability. How? Your destination NAT is working here. So when this router is going, okay. So what AC is doing, you will be going to ping to the network, which your address 11.1.1.125 will be get translated into 11.1.125. This address will be going to translate into the address, which is the local address of that network, which will be 10.1.1.25. And we understood that if it is in the same network, they will communicate without need of default gateway. So your response will go back and convert from this address to this address. And then it is going. Correct? And that is what happening here. Okay. So this is what your destination NAT. Now we'll do static NAT and then we'll go for policy NAT. Okay. So let's go on your router first. ASA, remove this information. Clear. Configure NAT object. Show NAT. Show xlet. No. Okay. So we are good to go. Now, in static, what we can discuss, consider you are having a dedicated server. Let's for you are preparing for CCI and you want to access our server. This is our one server and this is your another server. And when anybody from internet, let's say you are at your home, from your remote location, you want to access our server. So you will be going to request it on port 8080, but 8080 is a well-known port. And if whatever service we are running on a default port, hackers will be able to filter it. So they will be doing port scan. They will be using tools to collect data about the port IPs and the network. So default ports will be get converted into the something else in an organization. Organization will be using a different way to hide their infrastructure. So when you will be having static IP for your web browser or will be running your data center or server, so you will be having a different internal ports and the IP which you don't want to disclose to the outside world. So to achieve this, your firewall will be helping here for your static part. So see how. So let's add your default gateway on router 1 because we need it now. 10.1.1.10. And let's verify the reachability from router 1 here. And it's working. Good. Similar way, we need to check, can we take internet access? Yes, it's working. So far, 11.1.1 pi who's accessing to the 10.1.125. This is the inside router. Okay. So for now, only I'll be going to change the name of this routers to rack 1, and inside router 2, I'll be going to change its name to rack 2. These are all the servers which we are running. Now on ASA, we'll be going to create one object. So we will be using one public address, which will be your identity, which you are going to get it from outside world. Okay. So let's decide you are using here 150.1.1.1. This is your public address. And when you will be going to access a rack 1, you should not access on port number 80. So you will be going to take HTTP request on port number 80. So let's map your port number 80 to something like 555. This is for rack 1. So when you will be accessing rack 1, internally we'll be going to access it on this port. We don't want to serve this service on port number 80. We want to change it to something else. And here we'll be using HTTP request. 80 will be mapping with, let's say, 80 will be mapping with 666. And that's it. This is the mapping what we have to do. Okay. So see how we can do this. So we'll call one object network rack 1. Let's call rack -1. We're talking about okay, first let's go for your public IP. Let's decide to use public IP here. Object network. You can use the public IP which is in a background, which is 150.1.1.1. Okay, and that's it. Then you can go out, call the rack 1 which we created already. This is the network rack 1. For rack 1, what is your host? Which host we are talking about? We are talking about the router 1, which is what? 10.1.125, right? So we'll inform rack 1 means we are talking about router 1. And here the translation, what we have to do, anybody from inside to outside will be going to communicate, will be going to convert statically your which address? Your public address. Okay. Just a second. I need to do it again because I have done one thing. Clear config object. Show running object. Why? Because the IP address which we have to took it for public, and that name I again gave the route rack 1. So again it have the wrong address. So we'll do it from here. So here we'll use public IP, public -IP. Decide which address we are using. We decided to use 150.1.1.1. Come out. Now we can say object network. And we are talking about rack 1. So rack -1. For rack 1, who's my host? My host is 1.1.125. And here I want to do the NATing from inside to outside. So mapping of internal network to outside network, statically I'll be going to map with my public IP for service, which is TCP here. So TCP service I'll be going to map. You can use here a real specific like port, which is real port number 80, or you can also specify www. Both will work. So I'll specify one here with 80 and another natting I'll do for other, that I'll be going to use www. And now it is asking to map your what? Mapped port number. What port number you have to use? So we'll use, I want to use 555 for rack 1. Okay, what it is saying? Okay, spelling mistake. It's saying public spelling mistake should not be there. So done. Now this is for your rack 1. Now go for your rack 2 now. Let's say for rack 2 object network rack-2, and here which host we are talking about? We are talking about 1.1.126. For this host, NATing we will be mapping from inside to outside statically. What happened here? License warning. NATing we want to do here from inside to outside statically with what? With public IP. So with public IP. So with this address, we will be going to say service I'll be going to map with TCP, and here I'll not use 80 as a HTTP, I'll use www, which is HTTP only, and I'll be going to map with 666 and done. You can verify this, show NAT details. So your internal network will be mapped with this. Okay. Understood? You can also verify with show XLET table. The information will be shown here. Now, let's go outside. We are running debug here. So now we'll do one thing. We'll run here and debug all, debug IP packet details. Now go on outside. If I ping, I'm having reachability. If I ping, I'm having reachability on which IP? What is your IP here? 11.1.125. For which server? 10.1.1.25. But now, if you go to the internet PC, refresh it, see it's not working. Or go to the next page. Try to get the access. It will not work. Why? By default, it is working on which port? Port number 80. Now, anybody from outside now want to communicate to the server. So, what is your identity here? On this outside router one, what is your identity? 10.1.125. Correct? So, check here. If I say HTTP to the port number 55, HTTP has to come on. Let's close it and open it again. and see here. You are receiving the request. So let's check it on your ASA. Show running NAT. Show running objects. Okay. What public address you are taking? You have took one address here, ISP, which is 150.1.1.1. This address is a static address for your PC, but it is not available on port number 80. This is what we have to check. And this we need to be changed here, no? 150.1.1.1. And port number is what? 555. And see, it's working. You have to check what? CCI. It should connect to what? Rack 1. And here it is. You are connected to which rack? Rack 1. And if I change my port number, 666, I should connect to rack 2. Rack 2 is router 2 is not configured with HTTP. So let's quickly configure your inside router with HTTP here. First configure your username, call it admin, privilege 15, password is CCI, IP HTTP server, and if you want to do for secure server, you can do for secure server. And authentication, I would like to do locally. Now go back on a router PC and check. See, it's asking for it now. Admin, CCI. And you should connect it to rack 2. And that's what it's working. So this is called destination NAT. Correct? So this is how our internal server is also mapped in NH. If you see in NH, what happened? NH, we are having couple of racks, right? So what we have done? So in NH also, let's say you are having rack 3, rack 4, rack 5. Every rack we are having different devices. So we are having couple of servers, trainer server. So here 2-3 racks are for trainer server where you are having CCI security server, couple of CCI security, SDN server. Then we are having CCI lab preparation server. Then we are having student accessible server. So some server with students access. So how we are having like what we are having like multiple public IPs or what? No, we are having one public IP. If you see here, I don't know it's visible or not. Can you see? Can you confirm? Can you see this address? Yes. Adarsh, Archana, Viraj. You guys are there?
Yes, sir.
Can you see this address?
Yes.
So this is what public address we are having. Now on this public address, we are using different port numbers like 1,265,535. In this range, any port number you can use to map internal network, and router will be doing port forwarding. So you'll be able to access multiple server inside our infrastructure. And that's what we can do also with your ASA firewall. And that's what we understood here. Okay. So now we'll do policy NAT. So let's go here and remove the configuration from your ASA. And let's understand first what is the policy NAT is. Clear all the objects. Clear configuration which we have done for the objects for NATing. Show NAT. Show XLate. No. Good to go. Now understand what is policy NAT. Have you heard about something called PBR, policy based routing, or route filtering? Yes. Viraj, others. see what we are trying to do. We'll be going to consider now inside we discussed. Now we'll go and we'll discuss the outside. Now outside, consider you're having two branches. Let's call this outer router 1 is branch Pune. So this is your branch of Pune, and consider this is your outer branch which is in Goa. Okay, so I want everybody from this subnet. Okay, everybody from this subnet, if it is going for this particular department, so you should use a specific address. Consider anybody from here, if they are going for this server or this branch or this branch, your identity should be fixed. So if you go for this, let's call, you will be going with 100.100.1.1. And if you are going for Goa branch, your identity should be 200.2.2.2. So that's what we can configure here. So this is called policy-based routing. Anybody from internal network, if you want to go to the one site, you will be going with specific address. Anybody from this network, you want to go for another site, you will be using different network. So how we will be going to achieve this? Try to understand here. So on router, first we need to have the internal network. All we will be going to consider. So we'll be going with the subnet. So let's call the object here. So we'll say network, and this is what? Internal network. So we'll call here in for internal network. So NET for network. So internal network, and who want to go with all. So subnet, and we'll give all the subnet 10.1.1.0 last 24. All this subnet, then come out. One object for all internal network. Now what you want to do? You want to go for a specific address for Pune branch. So I'll also change your host name here for outer router. So host name is Pune-R1, and outer we will be changing with host with Goa-R2. Okay, outside we can't change our name, but here we can specify. So I'll just do one thing. I'll use here names Pune and Goa. I'll put it like here. Good. Love the lab and start. So come on AC, and on AC now you'll be going to need which address you want to convert from Pune, like from inside to Pune, which public address will be using, and from inside network to the Goa branch, what will be the another IP you will be having. So let's specify the addresses here. Okay, so come on. So this information we'll add it here. So we'll say Pune public address will be, which we will be using. Let's call 100.1.1.1, and we'll be using Goa public IP. Public IP. Let's call it 200.2.2.2. So this is two addresses what we are having. This is my public addresses for Pune and Goa. This is what I wanted to map here for inside network. Correct? So lock the lab. And let's do this. Now we'll be going to create one object to map which network? One object to hold public IP of your Pune network. So we'll call it like Pune public address for P. And what is that address? This is a single address. So Pune will be using 100.1.1.1. And similar way, we'll be going to create for Goa. And which address will be going to use? 200.2.2.2.2. Come out, show run objects. These are what objects we created so far. So these three address will be what? Three objects will be what? One for your internal network. So one object will hold identity for whole internal network. One object will be for public address of your Pune and another will be for public address for Goa. Now we need one object for a specific destination. Which destination you want to translate? What is your location ID? So here it is 11.1.1.120 for Pune and 11.1.1.20 like 126 is for Goa. So we'll be putting those in one object. So let's say object for network. So which branch we are talking about? We are talking about Pune branch. So let's put all in branch. So Pune branch, what is your address? The address we are talking about for Pune branch, which is 11.1.1.125. And come out object network Goa branch. And for Goa, we are talking about 11.1.1.126. And that's it. Now verify, show run objects. How many objects we created? We created these many addresses. One for internal network. This is too much. One for your internal network. One for your Pune public address, Goa public address, Pune branch address, Goa branch address. So how many we created? 5. So 5 objects what we need to have the policy-based routing. Sorry, policy-based NATing. So how will we going to do this? So let's see. Now we need to do NAT translation. So let's translate it. Let's call it NAT from inside to outside. Source will be now dynamically will be going to map for which network we are going to map your internal network. So what we use object in for internal hyphen net for network. My internal network I'll be going to map with my public address. So the public address of Pune. So what we have used Pune P. Pune hyphen P for public address will be mapping our internal address to the public address for destination. Which destination? Pune branch. How? Statically will be mapping to Pune branch. What is the Pune branch ID? The branch address will be what? So we'll be using Pune branch. So this is the public address what we are already having. So we don't want to, we can't convert this ISP address. So we have to use what? We'll be using now this will I have to type only. So let's say Pune hyphen branch to Pune hyphen branch. Same address to same address will translate. Means we can't change it. So we'll use same address to same address. So it will be same only. So if you do, does not match what Pune branch, spelling mistake. N missing. Branch. Done. And now nextly we'll do understand now here. Dynamically internal network will be going to do for Goa public address. Internal network will map with Goa's public address. For destination, statically will be doing for which branch? Goa branch. And with Goa branch. Then show running NAT. So this is the NAT what we configured. So you can also verify this information in your NAT details. This is what your source and original will be. So destination will be what? 100.1.1.1, 200.2.2.2. Okay. Now see, anybody from here try to ping to the specific network. So let's ping and verify, then we'll go there. So let's say 11.1.1.126. You're having reachability. You are pinging for which? 11.1.1.6. But check it on router 2. Do debug IP ICM. It's hitting. What is your identity here? How you are coming here? You are pinging from 10.network, but identity will be what? 200.2.2.2. And is it the same? Yes. Goa's public address will be 200.2.2.2. Let's verify from the same router 1. If you ping it to 25, what will be my ID? 55. $125. Got response? Check it on your router 1. What is your identity? Identity is 100.1.1.1. And this is what we planned. This is called destination. So policy based NATing. Now go on router 2 and do the same. Ping 11.1.1.125. You'll be having reachability, and 6. You'll be having reachability. And if you go on the device, you'll see your identity is what? Anybody from internal network ping, they will go and have the same identity as 200.2.2.2. Similar way on router also 100.1.1.1. Followed? Any doubts here? Archana, Adarsh, Viraj, you guys are following? Any doubt? So we can cover. So here we have completed your NATing. So how practice with the NATing? Okay. Now, let me stop this. So tomorrow we'll be going, like next session will be on Saturday, and Saturday we'll be going to start with your multi-context. We'll understand how we will be going to convert your this firewall into virtual firewall. So this one physical firewall will act as 2 different firewall. Okay. So one will be treating a one whole network, and another will be going to treat a whole another network. So we'll be going to divide your one physical firewall into multiple virtual firewalls, like your VLANs or VRF. So we'll discuss how we'll be going to convert this in multi-contexting. This is small overview for your next topic, what we'll be going to learn. Okay. So we will be going to wind up here. So if you have any doubt, you can let me know.